Hello everyone, this is Physics 2212 Lab 4. To start off, the purpose of this experiment was to use the loop rule and current conservation to predict the behavior of circuits containing resistors in series and parallel, and to use multimeters to measure the actual values of the conventional current and potential difference in the circuits, and examine the behavior of ohmic resistors and capacitors. And a quick result preview for this lab is that the calculated formula and online models results, they both align. Now here's key concepts that we used in this lab was the conservation of charge, loop rule, node rule, my bad, steady states, Ohm's law, and RC circuits. In part one of the experiment, we're looking at this circuit, and the prediction is that current 1 equals current 2 in the series circuits, which calculated to be 0.02, and this was proven in the online model. Now continue with part 1. Here are the results for the prediction of the change in voltage between different points throughout the circuits, as can be seen down here. The only three notable ones are change in voltage from A to B is 3, from D to C is negative 0.96, and from E to F is negative 2.04. All the rest resulted in no voltage change. Now the part 1 questions, starting from top to bottom. Multimeter has a high resistance, so current is moving very slow through it. And the second question, I2 equals 0.06 because the ammeter have low resistance, so the current will flow through it instead of the resistor. Now, when going through different resistors, the resistance ended up being 48, 102, 0, and 0. Now, part 2 of the experiment, where we'll be using RC circuits. The first one, we connected battery to a 10 ohm bulb and capacitor. It went from dim to bright to dim to no light, so the current decreases. Second time, we removed the battery. It also went dim to bright to no light, current drops to 0. The time to discharge with the 10 ohm one is about 12 seconds. And the time to discharge for the 20 ohm one is about 20 seconds. Now here are some data and graph. You can pause the video and watch it. And for the what ifs, what if we were doing this lab in real life and use the actual ammeter instead of ideal simulated ammeter? Is that the ammeter will have a small resistance and cause a lower current. And second, if you were doing this lab in real life and use a real battery to charge a real capacitor with no resistor in the circuits, how quickly will our ideal model predict the capacitor to reach full charge? Will this prediction happen in real life? Well, no resistor means current flows fast, capacitor will be charged very quickly. However, in real life, circuits have resistance to them, so this will not happen and it'll go slower. Thank you.